Okay, good morning to all. I'm Dimitris Bikiaris. I'm professor in Aristotle University of Thessaloniki. Thessaloniki is the second largest city in Greece, in the north part of Greece, but we have there the biggest university with more than 80,000 students, undergraduate, master's students, and PhD students. We coordinate this project and we have a very good collaboration with ISQ, with Elena in Biomac project, our previous project, with Carla here, Diago, and many others. The project, okay, sometimes we give a name to the project, but it's very difficult for the people, to know what this project deals. We call it REDONDO and deals we tried to solve one of the most difficult problems on the market. We have here a material, cross-linked polyethylene. It is a material that after cross-linking, we cannot do something, we cannot recycle, and this is a big problem, as we will see. It is a challenging project, and we try to solve this problem. How? We will see here. Okay, it doesn't work. Let's see. Okay, we can change from here. Okay, what this project deals? We need to produce some reversible design cross-linked materials, and we need to produce some polyethylene reversible cross-linked material that after cross-linking we can remelt it many times in order to recycle. This is the first task. The second task is, as we can see here, to produce also some nano additives, which will be saved also by design. All this used to produce nanocomposites. Nanocomposites are material that consists for a matrix, polymer matrix, and the additive is inside. We will see what nano additives will produce. All these nanocomposites will be used from our partners and users for the production of cables and pipes, two of the most hottest application of cross-linked polyethylene. After, we need to see that we can recycle, because this is the task, all these end materials, pipes and cables, and to develop of a circularity monitoring computational tool, we say place me tool, and establish safe by design and sustainable by design criteria reverse cross-linked polyethylene. This is very important because we need all of these materials to be safe and sustained by design. Okay, why cross-linked polyethylene is used to this application? Because it has very good properties, as we can see here. Improved properties, such as higher thermal stability, which is very important. The water that's circulated inside in our house is about 70 degrees Celsius. Polyethylene melts in 140 degrees Celsius. So we cannot use neat polyethylene. So we need to cross-link it to become a stuff material, to have a stuff structure. It melts again at 140 because it's a crystalline material, but it doesn't flow. So the pipe is kept there. It has a reduction in creep deformation, high chemical resistance because chlorine inside in all water circulated system, improve abrasion resistance, and greater impact strength, which is very important. Due to the formation of cross-linked polyethylene, does not behave like thermoplastic. As I said before, we cannot remelt it after and to produce a new material. For example, we can take the bottle for water or for Coca-Cola carbonated drinks, and after drinking the water to taking again the material and to produce a new bottle. In this case, we cannot reuse it, and this is a big problem. To solve this problem, REDONDO will develop reverse cross-linked reactions based on the formation of disulfide groups. This is the task from Aristotle University, and there's other reactions. is something new. These bones here, no. When are going to our hairdresser to make permanent, like Christina's hair. So cysteine became cysteine. Some disulfide bonds are produced, but these bonds here are not stable, and during time, our hairs are going again to the previous states. So that's why we wanted such bonds inside in cross-linked materials, because at high temperature, it will be decomposed and degrade and give again the thermoplastic material. To further reinforce with nanocomposites and composites all this, and to enhance the properties, especially we wanted to enhance thermal properties and also its thermal behavior. We have the implementation of our work project is consists from 4 different phases. In the first phase, we need to have some safe and sustainable by design material, study the determination of the specification and requirements associated with the development of cross-linked PECs and additives. Health risk, because, okay, we found some new materials, monomers to replace the previous, but what about the environmental assessment and the health risk? In the second phase, we need to produce all these reverse cross-linked polyethylene with these bonds, carbon, sulfur, and sulfur bonds for market pipes. And the second task, this other reaction, it is from our CNRS partner from Nomple in France. And this will be for cables production. The third phase is sustainable green and bio-based additives with, from our partners. We need here to produce some nano additives based on nanolignin and nanocellulose, and also we can functionalize with the important groups all of this to add inside in polyethylene to produce material with enhanced properties, flame retardant properties, for example, because for cables we need such properties. And finally, validation and demonstration activities of all this. This is the most difficult task here to produce. Our partner Ceylon is the leader from Czech Republic, producing today cross-linked polyethylene to produce the master batches that we needed to give to our end users to produce the pipes and to produce the cables. This is the most difficult task because, okay, we have done a lot of work in our institution, in our Aristotle University, and also in Montpellier. But after, we need to go from the research to pilot plan development to scale up and to final materials, which needs more than 4-5 years. Here are the consortium, 11 partners for 6 different countries, Aristotle University, CNRS, with the tasks that I mentioned before, to produce reversible in the lab scale cross-linked polyethylene. Ceylon from Czech Republic is the leader here in Europe for production of cross-linked polyethylene, given to our partners Interplast and KB for production of pipes and cables. Creative Nano and Itene will produce some nano additives based on nanolignin, modified nanolignin and nanocellulose and place for the production of some nanocomposites. The task is from Ayman from Spain. Itene also to do some health risk developments, AXA and RCD for innovation and implementation activities, dissemination, and ISQ here, you know very well what you are doing in your non-profit associated organization. So there are 8 work packages starting from the management of the project, but you can see that there is interaction and connection between all these work packages. I don't want to bother with such details. And the project and all our packages ends about 24, 36, and 48 months, which is the last of this project. We have done a lot of work. We presented the 2 previous days the workflow, very well work. Here is the milestones of our project. We are in the 3rd year, and we need here, which is the most difficult task, to produce some materials from Ceylon master batches to give to the end user to produce the pipe. And we hope next month we'll be able to produce all these pipes and to produce the cables. And we will finish the project in the 4th to 8th month. This is a very difficult project, as I said, it very difficult problem, because today all these materials, cross-linked polyethylene, then users, and after their life, we don't know what to do. We sieve in small grains, and we add in concrete and also in asphalt. We don't solve the problem, we hide the problem, and Redondo aims to solve this problem, because can you imagine an asphalt full with grains of polyethylene after UV radiation and tire friction? We produce a lot of microplastics, and the microplastics today are everywhere. Okay, we hope that succeed. As I said, it is a very difficult project, a very difficult task, but we are in a very good way thanks to the collaboration of our partners. Thank you very much for your attention.